everyone. Very excited to be here. Let's see, what's a good place to stand? This is good. I'm a small person, so it might take you in the back cranks a little bit of, like a telescope to see me. Yeah, super exciting part of this is being here and talking to actual engineers and architects. Last couple of years, sadly, I'm only getting invited to some sort of like a leadership conference, so I'm really excited and a little bit nervous just to talk about actual technology after a while. I'm going to talk about the lessons we had from scaling Trainline's architecture. And scaling will mean the usual things around like, hey, how do we handle more traffic? But that's not the only thing I'm going to talk about. I'm also going to talk about the things we have done to make it to make it possible to have more engineers work on our architecture at the same time, so we can speed up the pace of growth and the pace of innovation and all that. And I'm also going to talk about scaling the efficiency of the platform itself, so that as the platform grows, it grows in a way that's kind of efficient and cost efficient and all that. So you'll get to hear about business lens of productivity and kind of team impact, business lens of cost efficiency, and that kind of that side of like financial business impact, as well as actual traffic growth and being able to kind of handle more business. Right. So with that, where's my clicker? There we go. How many of you know what Trainline is? Okay, 30% of the room. This kind of, I probably expect something like that. So we are Europe's #1 rail digital platform. We retail rail tickets to users all around the world for rail travel in UK, Spain, France, Italy, really kind of most of Europe. But in addition to retailing tickets, we also follow users through the entire rail journey. So we're with them on the day, helping them with platform information, if there are any disruptions, helping them change their journeys, getting compensation for delays, as well as kind of if there are any plan changes in terms of kind of what they want to do with their ticket. So we provide all of that through our B2C brand, Trainline.com, as well as a white label solution to our partners in the carrier space, in the rail carrier space, as well as to other parties in the wider travel ecosystem, your GDSs, your TMCs, kind of, and anyone else kind of in the travel ecosystem who wants to have access and book rail. I'm going to mention a couple of numbers. I could have, like initially had like 30 numbers on this slide, and I was like, no one cares, too much. So I'm going to just give you just as a teaser of roughly size of the business, and then some numbers related to the traffic, although we will talk much more about that kind of as we go through the presentation, and then also just the team. I think that kind of gives you an idea of what the company is and technically what we're trying to solve. Oh, and by the way, sorry, I forgot to say, I have probably about 25-30 minutes of content. Let's see, maybe I kind of talk a little bit more, but we will have plenty of time in the end for questions. So as I'm going through all of this, if you have a question, if something springs to mind, feel free to kind of note it down, and we can cover it in the end. Right, so just to give you an idea in terms of size of business, we're a public company, we're well-established, profitable, and right now, last year we traded about 5 billion net ticket sales. So just kind of, I know this is not the room that would necessarily always care about money a lot, but just gives you an idea of kind of the scale in terms of technical impact as well. It's very difficult to pick one technical number that represents things, but I have just decided that maybe I show searches, which is we do around 350 searches per second for journeys and for origin destination pairs, and we do that over something like 3.8 million monthly unique routes. So if people look for Milan-Rome or Cambridge to London or kind of wherever else, that kind of gives you a problem space of search. And then we have about 500 people in tech and product organization, out of which I guess majority is tech, obviously. And if that's kind of not cool enough, this is cool, isn't it? I love this innovation. This just kind of gives you an idea of the problem space in the sense of we kind of know where each live train in Europe is at any given point in time. Can I do that again? Oh, I should have made it loop. I don't know how to do that. Anyway, this is the, just kind of, yeah, and A, that's a lot of data. B, it's a lot of actions that we need to do every time when you see these yellow or red dots, it means the train is delayed or getting canceled or getting changed or something like that, which means we need to do something with the customers that have tickets for that train, that we sold tickets for that train, to notify them in a certain way and kind of all that. So that kind of, this might be just a graphical representation of some of the scale of the problem and kind of effectively what we're dealing with. And then this was kind of really interesting one for me. When I joined, and I've been at Trainline now for, gosh, 3 years, coming up to in July, it's going to be 3 years. And I remember as I was joining, I was like, I love trains, very cool, just kind of like super happy to be doing this. And I was like, what do actually 450 engineers actually do? Like 2 of them build the app, 3 of them build the backend. What does everyone else do? No, I'm kidding. Obviously, I knew there is a bit more, but I was still kind of like, I'm not sure this is actually such a hard problem to be kind of requiring that many people. And then, like, I think over time, or certainly even within the first couple of months, it became obvious that certain problems were harder than I thought. And I'm going to talk about 3 of them, and that's maybe not extensive. That's certainly not an extensive list of everything that's hard about it, but these are the few where I was like, oh, shit, like actually that's kind of harder than I thought. The first one is aggregation of supply. So we have more than 270 API integrations with individual rail and bus carriers, rail and bus providers. And there is zero standardization in this space. It's kind of, you literally have one-off integration. There is no standardized API model. There isn't what for any of you that know airline industry, for example, what the GDSs like Amadeus have done, 30 or 40 years ago, which involved standardizing all the airline booking APIs. That didn't happen in rail. So it's like a lot of very custom integrations. And as you can imagine, that comes with problems of high maintenance costs because everyone is constantly updating their APIs. Non-trivial integration every time when you need to add a new carrier, a new kind of rail company launches. And then I would say even worse, journey search and planning combined journeys over that kind of, the very, very inconsistent and disintegrated set of APIs is a problem that needs to be solved because everyone has different API access patterns, but equally different limitations. For example, we get things like look-to-book ratios where we can only search and hit certain API within the certain limit of proportion compared to how many bookings we do through that company, as well as like sometimes pretty strict and very old school rate limits in terms of kind of what we can hit. So kind of a lot of complexity comes from that core idea that is ultimately the purpose of Trainline, which is the aggregation of all of the supply. One more thing that's sort of related to that is that Europe has 100 times more train stations than airports. So just also in terms of scale, there is a lot here. Getting those journey searches to work, especially combined across multiple APIs, and getting them to work fast, that was kind of the problem. Then when I joined, I was like, oh, actually, yeah, I guess that is harder than I thought. The second one, and this is by far not, whereas I think this level of aggregations of supply might be somewhat unique to the kind of rail industry aggregation. Transactions over a finite inventory are not, and I suspect many of you have worked on something similar at a certain stage, like the classic kind of Ticketmaster problem where you're not just selling something. In my previous career at Google, I was running part of Google Play Store, and we were selling apps, which involve certain complexity, but it's a digital product, so there is no limited number of them. We can sell as many apps as we want, or as many in-app products as we want. It's all kind of like digital, and you don't need to check the inventory or kind of anything like that. Right now, we're selling seats on unique trains in unique class with a unique fare, and kind of all of those have limited. It's quite limited, and you can understand that transactionally that's just much harder to solve. Kind of to make it reliable, to make it fast, and kind of all that. Right now, we handle about 1,300 transactions per minute at peak times. That's probably up, that's up from 0 in COVID times, but it's also up from, I think, probably something like 800, close to 3 years when I joined. So it sort of has been growing. Some of it because of as part of rail travel recovery as the economy was recovering post-COVID, and some of it as we were growing, and especially as we were growing in Europe. And yeah, I think I kind of covered that one. Does that resonate? Did any of you deal with like transactions over finite inventory and get like the complexity of that? A few hands, okay, yeah, this is the kind of, I don't know if everyone else is thinking like super easy, I don't know what you're talking about, it's kind of like, but no, there is layer of complexity here that kind of comes with it. And then the final thing that also ended up striking me at that kind of early stage that was harder is the speed at which people expect you to fulfill a ticket, to literally give them a barcode they can scan as they walk through the barrier gates is, you know, the expectations are high. It has to be within a second, right? It has to be basically instant. And that doesn't apply. I know, you know, when all of us, when we buy rail travel, we usually buy it for a couple of months in advance, at best couple of weeks in advance, right? And usually that email with an actual ticket arrives a couple of hours later, right? Like it very rarely it arrives instantly. We don't have that. Right now, about 60% of all of our tickets are bought on the day. And quite a lot of those are actually bought literally as people are walking into Charing Cross station and kind of getting the app on, getting the ticket on Trainline and scanning it straight away. So it's sort of from the point of completing transaction until people having the barcode they can scan on the barrier gates, and that, you know, involves a lot of industry level standard interaction with industry level processes so that the barrier gates can recognize the ticket as valid. You know, that's kind of, those expectations are pretty high. Right, okay. So that's some of the taster of some of the things that are hard. So now I'm actually going to go to the juice of the talk, which is going to be 3 lessons we had on scaling. And then again, as I talk about this, keep in mind the first one is going to be more around team and productivity and ultimately the impact of architecture, both how it enables us and how it slowed us down as we were scaling team sizes and changing our teams. The second one is going to be on the cost efficiency and kind of scaling the efficiency of the platform. And the third one is going to be on scaling with growth in traffic and achieving higher reliability, and or kind of like dealing with availability issues and reliability issues. Yeah, I think that's all I want to say here. So the first one, so each one of the lessons, I'm going to start with a story. And you need to kind of like follow me with the story, like, you know, bear with me, and then we'll eventually get the lesson, because kind of I think some of these are a bit more, some of these are pretty obvious, some of these are a bit more nuanced, so it's going to take us a second to get there. So when I joined back in, July 2021, it was really interesting that, you know, I think we had probably about 350 engineers. They were entirely organized in this cluster model. Do people know what cluster model is? It basically means organizing your teams around ownership of the parts of technical stack. So we had Android app team, an iOS team, and web team, gateway or like a backend for front end team, e-com, supply, a couple of different supply teams, order process. So all the teams were organized around that kind of part of ownership of the technical surface, which is a way to organize teams. I've seen it, you know, in other places as well. But at that size and scale, you know, 350, and we were growing by another 100, I think, over that year. It didn't work well. It's kind of the productivity of the team was pretty low, because what was kind of, and this was very quickly obvious kind of as I started looking, almost any project that you want to do involved at least 5 and often up to 10 different teams. So then it was this like very old school way of, you know, delivery managers managing massive mega spreadsheets with dependencies and kind of trying to plan, you know, trying to estimate everything up front and who's going to hand over to whom, when, in which sprint, and obviously everything will constantly get late and everything would take 3 times longer to build, and it just kind of like, it was pretty slow. So I was like, okay, right, this is, at this scale, this is not the right model for the team and kind of what we need to do here. So in, I think, January 2022, we did a massive reorg of the team where we kind of, we basically threw the entire structure and created this structure that's also fairly standard in the industry called platform and verticals. So we had platform or horizontals owning technical stack, and verticals being having all the people with different skill sets, your Android and iOS and web and .NET engineers and Ruby engineers and kind of everything you would need, shaped around clear ownership of product and business goals. So kind of that was the big change we ran around that. And then we had it for about 2 years. I think that served us well and served a certain purpose that it had, and kind of I'll come into that for a second. It certainly improved alignment of the team to goals and how much, you know, any random engineer would care about delivering something that makes a difference to the business. And you know, it obviously came with other challenges, like models like this always comes with this challenge of tension between platform teams and vertical teams, where vertical teams are trying to land stuff as quickly as they can, as they should, and platform teams are always pushing back and saying, whoa, no, you're hacking that up, no, you need to do it properly, can you please also refactor this while you do it and get rid of that, tag that, and kind of all that. And I think that tension is embedded function of the model and kind of good thing to be having, but sometimes it can be frustrating to people on both sides, as you can imagine. And literally just now, a couple of months ago, we have again reorganized in a slightly less drastic way, but we have reduced the ownership of the platform just to very core services that are absolutely touched and shared by everyone. And then the other, let's say 50% of the tech surface went into the verticals, which we then renamed diagonals. I know we're definitely stretching the metaphor here, so kind of bear with me. That one is not standard. I haven't really heard that one elsewhere, so, you know, heard it here first. And kind of that's the model we're trying now, and that was because we felt we'll get the best parts of platform and verticals, but we'll also be able to streamline and remove some of that tension that was happening previously between platform and verticals. Anyway, I can give a whole talk about this set of organizational changes. That's not what I'm doing here. I want to talk about the architectural implications of this set of changes and what it means, because I think that's more relevant for this audience. If any of you are interested about other lessons learned from these changes, all that, we can do that on some other occasion separately. The key question here with all three of the models is, effectively two, like who owns each part of the technical surface? Who's in charge of all the sustain work, mandatory technical upgrades? Who's in charge in terms of driving the technical strategy and the vision for that part of the code base? You know, moving you to the new patterns in, I don't know, like the latest trendy JavaScript framework. No, I'm kidding. We're not doing that. That's definitely not happening. But kind of who effectively does all that core work, both to sustain as well as to drive the technical roadmap, in addition to kind of who effectively builds all the features and all that. And then the second part, the second question here is like, which product or business or tech goal is the team on the hook for? So all three of these have different answers to the two questions. That just kind of defines the problem space. And effectively, what we kind of, and you know, it's not impossible that if you ask different people at Trainline, they might give you slightly different sort of the red-green lights on all of these. But I think roughly with my leadership team, we kind of aligned that with clusters at that size, that where we were, we had a very poor, oh gosh, sorry, I didn't say what A, P, and Q are. This is like, I'll fix that before I send the slides around. A is alignment of engineering investment to business goals. P is productivity, how much we're getting out of the team. And Q is the quality, like the quality of the technical work that's being produced in a way that translates to the risk in terms of like, are we adding technical debt? Are we making platform worse, or are we making it better? Kind of that trend. So we felt the clusters were pretty poor for alignment because no engineers cared about any of the product or business goals. They were just happy to tinker around in their part of the code because they didn't own anything end-to-end. Productivity wasn't great, again, end-to-end. Everyone was very productive in their little silo, but nothing was shipped fast end-to-end because there were too many teams involved and too many dependencies. And then quality was good because people worked on a very restrained, small part of the overall technology surface, and they were very good at it, and they cared about making it good, so the quality was green. When we moved to platform and verticals, alignment became super crisp, clear. You know, there was an engineer on the hook to grow our, or you know, team of engineers to grow our sales in France, and there was there was a team on the hook to improve monetization, and some that were on the hook to improve customer experience related to refunds or whatever. You know, it's kind of like, it was the goals were very clear, so alignment was perfect, even on the tech side where, you know, you had teams in charge of improving reliability or cost efficiency or all of that. Productivity was better, much better, but the problem with it is, again, because of that tension, verticals would say, no, actually, we don't feel productive because platform is constantly pushing back on us. And I think platform had a point to push back on kind of some of the things, but that's why that one is yellow. And then quality was actually also pretty good because platform team was policing all the contributions, so they were ensuring that quality. And now with the model where we moved, I think we slightly diluted the clarity of the alignment. However, I think we're really enabling productivity, so we're kind of flipping the model previously. And what I do want to say here is that I don't, I have my favorites among these, but I think the most important point is that different things work better at different times for a company. Like I think if you do one model for a really long time, sometimes it's just good to shift it a little bit because you get a different balance and you get a different kind of, so this is not necessarily, oh, this is the best and this is the worst, this is the right one, this is the wrong one. I think each organization will have something that works really well and that is the right thing for it at that time. But again, going back to my previous point, let's talk about what this means for, let's say, more technical audience when you think about it. I think it's pretty easy to establish that, customer and business needs don't respect architectural boundaries. Is there anyone that would disagree with that statement? Or maybe agree? Maybe agree? Anyone agrees? More people agree. There are a lot of people that are like, oh, I don't know what to think about it. I have no thought about it. I think it's, I think it's entirely fair to say customer business needs don't respect architectural boundaries. You can design the platform in the most architecturally beautiful way. Within months, I promise something will come up where you'll be like, oh gosh, that doesn't quite fit into this beautiful logical domain model that I've designed. Like, now we have to think about it. At the same time, org structure needs to evolve with the business because business priorities change and kind of what you need to do, that just simply needs to change. And along with that, the business strategy and org strategy, technology ownership will move as well. So kind of something where you thought that a certain set of e-commerce related functions will forever live with that one team, there might be a different way to look at it. There might be recurring payments and kind of one-off payments. There might be a completely different paradigm shift in terms of, I don't know, everyone switching to Google Pay and Apple Pay or whatever it is. Technology ownership will move and will need to move. If you're not moving it, I think you're being complacent or the organization is being complacent and not getting the most out of its technical team. So I think that the way to summarize all of this is like, who knows what Conway law is? Okay, that's almost everyone. It's basically this idea that technology ends up getting the shape of the organization that makes it. So kind of how you organize your teams, that's how your technology ends up being built. And my insight through this set of changes was that, like, okay, Conway law of course applies. It's just like it's a fact. But the sad thing is that there is no perfect reverse Conway maneuver. It's really hard to maneuver yourself out of the technical architecture that a certain organizational structure has designed. So kind of the actionable insight out of this, or the actionable advice, which you're free to take or leave, of course, like anything else I'll say. And some of this will be controversial, and I'm pretty sure some of you will disagree with kind of what I'm saying here. But I think it's really important to build technology in mind and to build architectures, keeping that fact of kind of ownership transfers and external contributions in mind. Like I think we need to plan for that. And specifically, I think what that means is enforcing consistency. Every eng manager or every architect will have their favorite pet tool and pet patterns or ways of path to production or kind of anything like that. I think the only responsible thing for leaders in the company is just to say, sorry, we appreciate you have your way and how you like doing things, but this is the company way, this is how we do it. And the main reason is that because that person probably won't be there in a couple of years, but even that team won't be there. The entire structure will look differently. So then if you end up having to patch, technology surface from in terms of a lot of different patterns and different sets of tools and different languages and different kind of whatnot, that's the thing that ends up slowing an organization massively. So kind of, because there is no perfect reverse Conway maneuver, the best thing you can do is enforce consistency, and then it's easier to, how would I say this? It's easier to transfer Lego blocks rather than entire custom built items, because then you can just kind of reassemble Lego blocks in a different way. So yeah, so that's the first lesson. Consistency is king. As few languages and technologies as possible. Build technology for transferability of ownership and external contributions, even when it comes at the expense of autonomy, of kind of individual, and I know engineers take that very personally, that autonomy. I did as well when I was writing code. But I think ultimately, when you look from way higher up, kind of in terms of organization, the only thing that makes sense over 3 or 5 or 10 or 15 years. You know, Trainline has been around for kind of 20 years and has technology. We still have some stuff in production that's been written 15 years ago. And like, I think the best you can do is just like try to keep kind of things as consistent as possible with, you know, few languages, few technologies, and build everything for that kind of transferability. Okay, first lesson, done. Should we go to the second one? Okay, someone could have said yes. Like, need a bit more engagement, come on guys. Right, we're gonna talk about costs. And this is an interesting one because when I was at Google, we never had to worry about production costs at all. Google had all these endless data centers and it was all kind of free. And you could just, you know, it's kind of like I was like a new grad software engineer and I could deploy something that I now know costs probably hundreds of thousands of, you know, per year, millions maybe, kind of just in terms of volume. I think Google has potentially changed that philosophy a little bit in the last couple of years, but also joining, you know, the real business also made me realize like, oh, holy shit, actually, and just I'll give you one fact for Trainline, our AWS bill is about 25% of our overall software engineer compensation bill, if you get what I mean. So it's sort of, it's non-trivial, right? Like it's kind of, it's a meaningful part of the business, and I can easily make a case that, hey, we should spend 10 people worth of time for a year if we're gonna save 10%. I'm not sure if that math exactly. I think, actually, no, I think that math works. If that ends up being ROI positive for the company. How many of you had to worry about production costs? Okay, that's actually more than I would have thought. Most people had to worry about it. This is like, that's good. That's like, it's kind of, that's the, so this will hopefully be useful for you. So when we realized that we were really growing over the last couple of years, and it felt like cost of platform was growing not miles faster than the traffic, but a bit faster than traffic. And I was kind of like, I like to run things in an efficient way, just kind of I take, you know, it's my engineering pride, kind of to do it in that way. So I was like, okay, let's take a goal. We don't have to do anything super drastic. We're not being, you know, CFO is not asking me for drastic cuts, but I think just to make ourselves disciplined and make sure that we're running kind of like a tight ship, let's take on a goal that we're gonna drive down the kind of at least annual run rate, if not like kind of the entire annual bill, 10% down in terms of production costs. So then we looked kind of with my leads, how would that even look? What are the levers we have? We have a massive surface, by the way. We're very microservice oriented, we have like something like 700 services. We have more than 100 databases. And, you know, I have opinions on whether that's right or wrong, whether that's too much, but I think, you know, having maybe more microservices than engineers is an interesting one, but, you know, it kind of works. This is the, so it's sort of, it's not like, the reason I say that is because when you look at the surface, it's not immediately obvious where the flab is. You don't know what's efficient, what's not. There is a lot of stuff, a lot of services, a lot of jobs, a lot of databases, a lot of, you know, production platform, a data platform, and like a lot of different things. So we kind of looked a little bit like, okay, at least what levers would we have? And we thought about all of these kind of like, okay, we could look and there's probably some unneeded data we could clean up. We could consolidate non-production environments. Maybe we don't need like 7 non-production environments. Maybe we can drop 1 and that gets us some savings. We can review probably some old low-value services that are either deprecated, orphaned. You know, there might be stuff returned down there. We obviously instantly had this idea of like, right, are we even right-sized? Are we over-provisioning kind of the platform like so we need to review kind of just overall scale. We can look at the data retention policies. And then the tricky one, you know, reviewing architectural choices that we made for services. Like I think the team has gone very hot for like cloud functions for Lambdas in the past year. So I was like, is that actually efficient? Should we have more longer running services, or should we shift some of the long running services to cloud functions and so on? So this is not necessarily extensive list, kind of like that there's probably more one can do to kind of when you think about the overall cloud cost, but these are some of the things that I could think about. Or that we thought about as a team. And some of them are lower impact and risk. Some of them are higher impact and risk. And now in hindsight, I wish we were a bit more explicit around those things up front. But we kind of made this list. And then we sort of decided that we're just going to delegate this problem down. We have smart engineers. We have smart engineering leaders. we're going to go to all of our teams that own parts of technology stack, teams in the platform, and we're going to tell them, each one of you is on the hook to drive 10% of the bill down for your area. We had a good enough attribution so we would know what's kind of driving the costs. I can't remember if this is on this slide or the next slide. No, kind of, we'll do it here. Can anyone guess what went wrong with that? Everyone too shy. No one wants to. Like, anyway, just it was good to give you a minute just to think about like what you think would have gone wrong. I thought it was a perfectly valid plan. I was like, oh, it's too hard to figure out top down where the flab is, but individual teams know their systems much more. So we'll just split the bill and we'll tell them each one of you brings your part of the bill by 10%, and that should be fine. The problem turned out, of course, that some parts of the platform are already very efficient and others weren't. Like, it's kind of like the reward is disproportionate in these areas, and it's very difficult to that 10% for some teams meant they had to really dig in and either spend unnecessarily a lot of engineering time getting the savings, or they started doing risky things, which is actually what ended up being more of a problem for us. Specifically, most of them, sorry, just going to the previous slide, instead of, like we were hoping kind of they'll go review architecture choices and they'll switch, lambdas to kind of long-running servers and kind of a few of these different things. What most of them did, they were like, okay, I have a goal to drive this down by 10%. I think I can probably, scale a bunch of things down and move from, having, 7 instances of this server to having 5 and maybe kind of all that. Which in some cases worked and it was fine, but equally in the scope of 3 months, we had like something like 4 outages caused by under-provisioning kind of services. Because it's one of those where you get it out and you're sort of like, oh, it seems like it's working. But, as we hit our, I don't even know what's the most popular day of the week anymore. I think it used to be Wednesday for a while, and I think now it's Tuesday. Tuesday is the peak morning traffic for us. And you do some changes, Wednesday or Thursday, and then a couple of days later, as we hit the peak, the auto-scaling doesn't work fast enough, or something else goes wrong related to kind of being under provision, and kind of platform goes down in the morning peak, in the worst time when it should be going live. So that's kind of some of the stories effectively that happened. Like, ultimately ended up meaning, I think we did projects which did give us 10% savings, but were possibly not the best value for money, because like engineers ended up spending more time than they should have really. And then we also had these unintended consequences in terms of outages, where kind of people went for what felt like a simple way to save money, but really was actually not what we needed to do at all. So kind of the so what of this one is like, obviously cost management is important for long-term efficiency of the platform. However, understanding where flab is in a very large technical system with a lot of, especially very large kind of fragmented microservice-based system, does sadly require a dose of centralized thinking. And I think just kind of delegating that problem down doesn't work, which is kind of that was my lesson, and I was kind of very sad to learn that. Equally, predicting which cost-reducing efforts are worthy can be tricky, especially for people who don't have maybe the full big picture, kind of, but you only know their part of the stack. So yeah, the lesson here was, for me, was kind of like, don't blindly push down cost-saving goals to individual teams. There are more ways it can go wrong than necessarily right. And if I were to do something like this again, I probably would have had a bit more of a centralized task force that can work with individual teams, but kind of evaluate where is the investment to save actually worth it versus not. Yeah, so that's basically it. So manage system cost savings efforts centrally. I think fully delegating ends up kind of backfiring, I would say. Right, last lesson. How are we doing with time? Oh my goodness, okay, I'm talking way slower than I was planning. This is the last one. This one is going to be, so the first one was more kind of team productivity impact and scaling that. The second one was scaling efficiency of the platform. And the third one is scaling for growth in traffic and reliability. I am going to briefly try to cover 3 big bouts of outages we had. And, this stays in this room. Please don't talk to the press about what drove our outages at the time. But it's the... and sadly, yeah, they did. This last bout did end up in the press, so that was sad. And I feel each one of these almost could be a talk on its own. As you know, every good kind of outage story has a kind of like a nice story to it. But very briefly, I'll try to cover, in October 2021, just a couple of, I think I barely passed my probation, or maybe didn't even yet. And Trainline goes down for something like 4 hours one day, and then it goes down. Oh, no, sorry, yeah, I think it goes down 4 hours one day, and then goes down 2 hours next day. So disaster, like really, really bad. What we realized happened was that at that stage, world was again recovering from COVID. We were recovering from close to zero traffic back to what was starting to be historical maximums, kind of like day after day and week after week. And we had the entire time through COVID, the software development didn't stop at all. Like Trainline even didn't lay off any people. So you had 18 months, let's say, of 350 engineers writing code that was never tested at scale, right? So like, what could possibly go wrong when that happens? Like imagine like batching up 18 months of changes, and then suddenly kind of it goes to production. So it was sort of like loose everywhere, and it wasn't like one simple cause, but the biggest one that we realized in this particular instance was that with that many, because it's very microservice oriented, a lot of new services have been added, and all of them were maintaining connections to the database. And especially as they were scaling at peak times, they were creating more and more connections. So ultimately, the biggest thing that was kind of causing the outage was the contention in terms of database connections. So we were kind of running out of pools. And this is especially in the part of the platform where we still have relational databases. We are on an absolute mission to entirely move to cloud-native storage, but we still have some relational data, or actually we still have plenty of relational databases, and this was kind of the bottleneck, where we have them hosted on a single, even if it's a mega machine, it's still kind of hosted on a single machine and cannot keep up with kind of that many with that many connections. So anyway, that got tweaked, tuned, we survived that period, and we were kind of good for a while. So then I don't know what happens in the fall. Now I have a little bit of PTSD every time it comes to October and November, and I just don't know what's going to be next. But like somehow completely unrelated, but exactly a year later, we ended up getting into this place where again, sort of the database was knocking out. I think the previous one was some old oracles, and this one was the SQL Server. So it's not exactly the same thing, but it was kind of knocking out. And we kind of didn't see it coming. We were sort of like, we thought we have super good observability, we keep an eye on everything, and it just kind of starts happening. And again, like it's not like when you do a bad push and you roll back within a couple of minutes and it's all saved. This is kind of like, again, hour plus long outages until we switch to a new replica of the database. Just kind of like not good stuff. It took a while to analyze what happened, but basically, over that year, we have been adding more and more of these features that are not purely related to transaction of buying a train ticket, but are actually related to the journey itself. So to traveling, you saw the nice map with trains moving. So kind of we have a lot of features related to that, where you can follow your journey, you can get a notification of like whatever the platform, the change, the kind of all that. All of those additional flows that are related to journey experience have actually been talking to the orders database, because they need to know what train you're on. That's kind of how it was designed. And most of our observability was centered on all of our transactional flows, not on all of those other flows. So what happened kind of over the year was that gradually the traffic mix shift changed, and the load on the orders significantly increased. And that, because it happened gradually, we kind of didn't really notice, and especially because it happened we didn't think that's where it's going to go wrong, It's like, which is sort of obvious. That's how all stuff goes wrong. You didn't expect to go wrong where it does. So anyway, we had to do some more kind of database-related stuff in kind of to fix that, and we just sort of survived it. So that was bad. And then just a couple of months ago, November this year, we had a fairly insane bout of DDoS attacks from what may or may not be attributed to some nation states related to conflicts that sadly we have in Europe right now. Most of the travel sector is seeing this. I don't know if any of you here are work in travel sector, but we're not the only ones. Kind of many other companies are seeing that. So as that was happening, we had to significantly tighten up our DDoS protections and change a few other things related to that. And then, just as we were like feeling good about it, we were like, oh yeah, they're hitting us so hard, and we were like, no, we're holding up, like we're not buckling at all. We just go down one day, like for hour and a half, whatever. That was the stuff that ended up in press. As a matter of fact, it happened a couple of times in the scope of a month. And as we dug in, initially it looked like we were getting DDoS attacked. But it wasn't that. It just kind of there were sloppy retry strategies all around the stack. We didn't really have a very coordinated retry, strategy overall, like who retries what and where. And even small issues of like a network blips or like something that goes wrong could snowball into this fact that where we end up DDoSing ourselves because everything starts, something is down, and then everything starts, clients retries, and the backend front-end retries, and backend services retries, kind of all that, and that ends up, like creating 10x load that eventually kind of brings the platform down. So that was fun, and anyway, kind of resolved eventually. So sorry if I moved through all of this very quickly. Obviously, there is way more detail and nuance in kind of each one of these war stories. But what's common about all of these? And this is kind of the architectural lesson that I kind of, that I got out of it. None of these were caused by a single team, a single change, or a single regression. And that's where it starts to get really, really difficult. It was, for each one of them, it was a lot of straws, a lot of paper cuts, if you wish, that ultimately cause you to bleed to death, if that's not too brutal of a metaphor. But it's kind of like that. But that's kind of how it goes, right? Like you sort of, it's not like you can point to this one change and then all your best DevOps processes and you can very quickly detect it and roll it back and kind of all that. No, things build up over time, just kind of like sloppiness in certain area, multiplied by a large team, everyone kind of chasing their own goals, and a very microservice kind of a spread out architecture like that. So kind of the so what is predicting a bottleneck in a large microservice-based system is really hard. Kind of like I still don't know if we quite know how to predict it. You don't know what you don't know. Often you're looking at the tragedy of commons. It's not like one, again, going back to that thing, it's not one team gets it wrong. It's, everyone just adds a few too many database connections. Everyone just adds a few too many retries. Everyone optimizes slightly wrongly for scaling, and it just kind of eventually the whole thing bubbles up. So the best lesson I could get out of this, and I think we're still kind of trying to learn and figure out how we can handle this better, is regularly review longer-term traffic mix or load changes. I think we're pretty good, well, so certainly Trainline is pretty good at like doing all the release by release or day by day changes or kind of like all of that is automated. You have alerting, monitoring, like all of that is pretty solid. But you sometimes need someone to sit once a quarter and look like, hey, how did actually mix on a couple of critical databases or services change over the past 6 months or something like that? Because what is that telling us? Are we, where is going to be the next bottleneck and what's going to be so I think that's the one, like just that's something that we're not kind of trying to put into action. And then microservice fleet coordination is absolutely critical. Again, sort of it's having to guide teams and have like a really strong architecture function or principal engineering function or however you want to call it, but someone who's guiding teams, who's looking at the big picture on top of kind of individual ownership of which teams own which part, and guiding teams on things like that could add up to create kind of a lot of mess, so like retry strategies or scaling policies or kind of anything that speaks to any scarce resource that's downstream. So yeah, so that's that lesson. Observe over longer term, coordinate microservice fleet. That's the last one. And that's kind of it. Yeah, we're going to have a couple of minutes for questions, but just very quick recap of the 3 lessons. Consistency is king. I think it's absolutely critical for productivity in the long run. If you're, in a Series A startup or seed round that's just trying to churn something out very quickly and you can throw away that technology, then you won't care. But if you're genuinely building a business where technology should survive for 5 or 10 or 15 years, then I think just like insisting on consistency, even if engineers won't love it. Manage system cost-saving efforts centrally, because delegation just doesn't really work. People lose the wider context. And then observe over longer term and coordinate microservice fleet to avoid many outages. Thank you. I think that's all I had. So please, any questions?
Any questions?
5 minutes, yeah. It's difficult for me to, I'm seeing some hands, but it's a bit difficult from lights. I see some in the back over there.
Someone bring in a mic?
Oh, there was one over here as well, yeah.
I don't see anything.
Or if you shout really loudly, I can repeat the question for the recording later as well.
Yeah, go on if you
Thank you for the talk. You've mentioned building and architecting towards changing the structure and people.
Yep.
That intuitively goes against
Build it, own
optimizing
it.
for knowledge and
Yep.
and change management in the near time. How do you balance that?
Optimizing for, so I think, so it's a very good question. I think there is a question here of, you know, short, medium, long term. I think there is something where, you know, people absolutely love you build it, you own it. And I really believe that. Like, it's kind of as a strategy, like you should carry the pager and pay the, you know, being paged in the middle of the night cost of if you don't architect or build something properly. However, that really only applies for the first, 6 months of service, 9, maybe up to a year. After that, again, that person who built it is going to move on anyway, right? Like, this is a fast-moving industry. Talent moves around. People will want a new challenge, kind of all that. So kind of, the way we think about it is like, you build it, you own it, but eventually you need to be ready to hand it over. And when we had platform verticals model, that was the model. So vertical would build a new service. They would be on the hook for it for like 6 or 9 months. The relevant parts of the platform would advise through that period what do they need, what's the criteria they need the service to pass for them to adopt it. But the idea would be that within 6 to 12 months they adopt it. So it's kind of like, so that there is that transition that kind of forces you to, and it's also, this is hard, right? Like, it's not like, kind of we always get it right, and this is the thing that causes contention in the teams, all that. But I think trying to pull teams back out of that mindset, because I've seen too many times where you end up with a bus factor of 1, and there's only one person who knows the service, and holy shit, no one dares to touch it because it's going to, and that's not good. This is kind of like, and especially if you want to have an agile organization that moves and really always focuses on the most important things, you need to have these Lego blocks that anyone is at least moderately comfortable picking up and saying, okay, yes, I'm not an expert, but I'm comfortable picking this up, and I can, kind of like take care of it and learn more and kind of all that. Maybe just one more, yeah. Over there in the back.
Thank you. I have a question about the first lesson that you mentioned, the consistency. I mean, if you think about maybe 5 years ago or maybe 10, when the microservices were out, we were so proud that they can be built with different languages, that they're not owned by the team, autonomy. Now, after that time, today we're talking about consistency, and then we say it's the king. But do you think it's the future? Do you see any downside to it? How do you see that?
Yeah, gosh, I have so many opinions on this. Let me try to be constructive on it. So I think like we already have like 5. Like, you already need to have different languages for the front ends, right? So that in our case that ends up being 3 different, like Android and iOS, or certainly, well, 2 on Android, but let's not even get into that. You have that kind of fragmentation of the skill set that you have in the organization. Then on the back end, we have most of stuff in .NET, and then we have some Ruby stuff that came through acquisition that was never, it was kind of always too big to re-platform, and it always stayed as a sort of thing. So it's really tricky when you need to put a cross-functional team that needs to deliver something, even if it's simple freaking one field being plumbed from the database to the UI, something that's meant to be very, very simple. You still sort of need like 10 people to do it, which I find almost laughable. It's just kind of, it's ridiculous. It's kind of like, because you need your Android pair and iOS pair and like .NET pair and Ruby pair, kind of all, it's just like, so some of that complexity is hard to get around because of native platforms like Android and iOS having their own languages, and it's kind of, but that's why I would really try to bring it down. I kind of like, I know engineers don't love it, but like I kind of draw the line and say like, no, sorry. Like, I think it's important to leave a little bit of space for people to innovate and try new things. But if the new thing works well and is approved, then kind of there needs to be a path for making it official thing for everything and everyone else. I think just freely letting everyone choose their own thing I think within very quickly, I think it just completely is unmanageable. It kind of, if the business becomes successful, there is no, there's no path. What do you do a few years down the line? And I think that's all we're going to have time for today. I'm going to stick around for a little bit more somewhere here in case you guys want to ask any questions one-to-one. And thank you so much. Thanks for listening.